Welcome to this instructional video on using the reaction simulation program to investigate the factors affecting the rate of the reaction between calcium carbonate and hydrochloric acid. When you open the simulation using the link on the worksheet, you'll notice a diagram on the left with gray particles arranged as a solid representing calcium carbonate chips at the center and red dots representing hydrochloric acid particles moving randomly in the aqueous solution. In this experiment, you can adjust three variables: the number of pieces of calcium carbonate, the concentration of hydrochloric acid, and the temperature of the solution. To start your experiment, first select one of these factors as your independent variable. For this demonstration, I'll investigate the effect of temperature on the reaction rate. Consequently, I will keep the number of calcium carbonate pieces and the concentration of hydrochloric acid set at the same values for the whole experiment. They are my control variables. With these control variables fixed, I'll set my first temperature value at 0 degrees centigrade. To begin the trial, click Start Experiment. You will observe acid particles moving and colliding with the calcium carbonate, producing small blue dots representing carbon dioxide gas. The graph on the right displays the volume of carbon dioxide collected in the gas syringe over time. To conduct a preliminary trial and check for a noticeable impact, I'll raise the temperature to 100 degrees and click New Trial, which resets the simulation. Clicking Start Experiment again, observe how increased temperature raises the kinetic energy, causing particles to move faster and collide with greater energy, significantly speeding up the reaction rate, as evident in the graph. For the formal experiment, reset the simulation to your initial values, in this example, back to 0 degrees. Repeat the experiment 5 times with the same settings by pressing New Trial and then Start Experiment each time. This repetition allows you to calculate a reliable mean rate of reaction. After completing 5 trials, click Export to CSV to download your data. Import this CSV file into the Google Sheets spreadsheet with your process data table. To make sure this does not interfere with your data table, click on a cell to the right side of the processed data table and choose the option to replace data at selected cell. If we plot one set of these results, you can see that the reaction begins at a fast linear rate, which then curves as the rate decreases when the reactants begin to be used up by the reaction. To compare the rates of reaction for the different values of the independent variable, we will compare the first part of this line, where the rate is the fastest. To do this, we will select the volume of CO2 produced at 50 seconds. Copy the results for 50 seconds for all 5 trials into the new raw data table. You can now delete the raw data table you imported. We can calculate the rate of the reaction for each trial by dividing the volume of CO2 produced by 50 to give us the rate in centimeters cubed per second. Using the spreadsheet function, you can easily calculate this result for all 5 trials. You will now need to repeat this exercise for 4 more values of your independent variable in order to complete your process data table and be able to analyze the effect that your chosen independent variable has on the rate of the reaction. Thank you for watching. Good luck with your experiment.